welcome to our video Independent Events Part 2. This time we're going to look at some worded problems. This is example 2 following on from example 1 in video number 1. The probability a family in a certain town owns a sedan car, which we've labelled S, is 0.25, and the probability they own a TV is 0.75. Forgot to put in there, a TV should be a T. If these events are independent, find the probability that A family selected at random owns a TV set and a sedan car, and B, the probability that a family selected at random owns a car or a TV set. So if we're looking at answering part A, the very first thing we need to do is define our variables in a worded problem, or in a probability problem, it's defining our sets and outcomes. So we've already got S for sedan car and T for TV. If you weren't given these two letters, you could choose your own letters. You could choose A for here and B for here, or you could choose C for car and T for TV. Completely up to you, but if it's given in the question, you must use the letters that are in the question. So I'm just going to write it out fully. Let S equal the probability that the family owns a sedan, and T equals the probability that the family owns a TV set. This is a full definition written out. Please don't be tempted to write S equals sedan and T equals TV, because that's only half a definition. It's not telling us what about a sedan. Is it that 3 people drive a sedan in the car, or is it that they would like to buy a sedan? So you must make sure you're defining it properly with a full sentence. Question A. Find the probability that a family selected at random owns a TV set and a sedan car. I would say the most important word in that question A is the word and. And we know that and means intersection. So what we're trying to find is the probability of S intersection T. So useful to have that there. First step is to define our outcomes. Once we've done that, our next step is to write out the probabilities that we already know from the question. We know the probability of S, sedan car, is 0.25. And the probability of T for TV is 0.75. Now, we also now know, we've been told in the question that the events are independent, so we can use our independent rule, which says probability of S intercept T equals probability of S times the probability of T. 0.25 times 0.75, and it equals 0.1875. I'll just put here, this is the independent events rule. S-intercept T is what we're looking for, and this is our solution here for part A. Part B. The question is, what is the probability that a family selected at random owns a car or a TV set? So most important word there is or, which means union. So we're looking for probability of S union T. Using our rule from earlier that has union in it, we get probability of S union T is probability of S plus the probability of T minus the probability of S intercept T. Hopefully you remember that rule. We get 0.25 plus 0.75 minus 0.1875, which equals it's not a great zero, 0.8125. So that's the probability of S union T, which is what we're looking for here. Thanks for watching the video today.